Okay.
Sorry, Bill.
And we also have made some improvements over the years, and our process we really think is working quite well. We needed to detail exactly what kind of performance data we want to see, and we've also been very careful to detail the process for establishing production targets when warm mix is used, because we did not want warm mix to result in lower asphalt content mixes. We just wanted it to be able to facilitate the benefits of using warm mix without drying out mixes. That's worked well for us. So right now we have 13 technologies approved. 10 of those are additives, are foams, and we have 15 contracts that are certified to produce warm mix on our projects at their discretion. So let's go to the start of our warm mix use here in Colorado. And again, it really started because we have challenging conditions to do typical construction in. And I-70 west of Denver is one of the main corridors in our state and nationally to get from east to west and vice versa. But it's largely how we supply our ski industry and all the other industries along this corridor. And it is high elevation, and it has a lot of traffic, and it can be very challenging even where we're allowed to daytime pave in that particular corridor. Night construction is pretty frequent on I-70 because of traffic constraints, and at night it's even colder at 10,000 feet than it is during the daytime. As you can imagine, we use warm mix to facilitate compaction at those lower temperatures. And we had some test sections that we started with installing in probably the most challenging pavement condition, I think, in the United States, right at the Eisenhower Tunnel. I'll tell you about that a little bit. But it performed very well, and we now have statewide use. So this project that I'm going to talk about now is 70 miles west of Denver. The lowest elevation is 8,800 feet, and it goes all the way up to the Continental Divide at 11,100 feet at the Eisenhower-Johnson Tunnel. So this is one of the end of the projects. So the project goes out the screen behind you and down the hill all the way to the town of Silverthorne. But in this image, this is the Eisenhower-Johnson Memorial Tunnel portal, and it's at over 11,000 feet. So it's quite chilly up there, even in the daytime. You can see the snow's not going anywhere. Difficult conditions, 35 inches of precipitation a year on this project, 200 inches of snowfall. Look at the freeze-thaw cycles, pretty significant. It's a torture chamber for pavement. Very cool conditions in summer. I've already talked about this plot. This represents the lowest elevation on the project. It's much more challenging up near the Johnson Tunnel. 30,000 AEDT, that was at the time of construction. It's higher than that now. 10% trucks. The project was designed for 4.85 million easels for a 10-year design. Pretty extreme conditions in the winter. I don't know, those of you that have a Hamburg machine, it seems like child's play compared to the conditions that pavements have to withstand at this location. 65 of 76 days there in the year after construction of this project, it snowed. 128 chain days. That means every truck required to chain up before they can go up and over and through this project. So that's very, very hard on pavements, and that's where we built one of our primary warm mix test sections that got us going. This was a 2.5-inch mill and fill. We had a Verosassobit and Evertherm all demonstrated on this project. In our case, an SX mix in Colorado is a 1/2-inch nominal maximum mix. So you'll see that throughout. This was an SX mix, 58-28 binder, 75 gyration design, and full volumetrics for pay. The warm mix produced at 250. The hot mix in the other sections on this job, we had fully controlled demonstration project and then monitoring, produced above 280 degrees. We had the same density requirements for both warm and hot mix, and the same compaction process was followed by the contractor. The warm mix was about 240 behind the paver. At nighttime at this elevation, very thin air, you usually see a lot of fumes from hot mix. Not in this case. Very quickly, some field data just to give you a flavor of what was happening on this project. As you go left to right across these columns, you're going up in elevation. So the test sections and the control for, say, the Advera were placed at a lower elevation than the Evotherm, which was placed at the highest elevation on the project. And you can see temperature drops with elevation, and that's on every single project here. So we were down to 36 degrees paving on this particular project. You see the mix production temperatures there. It's worth to note the mix temperature at the screed. You can see right about where we needed to be throughout, 240 down to 230 for the mix behind the screed. Densities are all good. Densities are all within specification and comparable between hot and the warm mix. A little bit on the lab data, because I think it's worth noting that there will be an impact typically on laboratory voids due to the drop-in of an additive of any flavor. And you can see we run all of our mix at our historic HMA laboratory compaction temperatures. It keeps us consistent and allows us to operate labs that test multiple projects, and we test them all at the 280 degree temperature as it was for this particular mix. And then we acknowledge that there's going to be, through testing up front, all prescribed in CP59, there's going to be an impact on volumetrics. We determine that at the start of the project, and then we set volumetric targets accordingly. So in this case, we established lower volumetric targets for production because we're going to keep the AC content at the hot mix level, and then we're going to add the additive, and we know it's going to impact voids, but we want to account for it so the contractor does not get penalized. You can see there was an impact on voids. It's worth noting, and it's making sure that our contractors are aware and we are testing accordingly. Go to the next slide here. Very well documented project, both at the end of the 3-year period and also a part of the NCHRP long-term warm mix performance studies. Excellent performance throughout. You can read about them in these 2 studies, equal to or better than the hot mix on the project. This is an image of the warm mix. You're standing in the middle of the warm mix lane, and it's hot mix on both sides for comparison. So that was a cold climate challenging condition. We also have cold combined with other challenges. Let me tell you about this particular project. State Highway 9 is up in one of the north high parks up in the mountains in Colorado. Traffic's not real high, and the trucks aren't real high. It's a low volume road, but the elevation's still high, and it's relatively cold, -28 to -34 in the PG grading. This was an old pavement, last worked on in '82. Sometimes back in 1969 was the last pavement work done on this project. But it did have pretty consistent chip seals applied, certainly crack seals applied throughout. So it was well maintained, but there were transverse cracks every 10 to 15 feet throughout this project. We obviously had to mill some isolated bad spots, but for the large part, the pavement was in pretty decent structural condition, just old. And so we have challenges like many states with doing the best we can with limited funds, and for some of these low ADT roads, we have to limit how much money we're going to be able to expend on those. So we really needed to avoid an intermediate treatment just to get rid of the crack seal. And so we didn't want to do any heater treatments beforehand or shallow milling beforehand to eliminate that crack seal, because we've had routine problems with trying to put an overlay straight on a crack sealed pavement. Causes bumps almost every time. We really needed to follow our guidelines and restrictions statewide for how much we can expend on our low volume roads. So we just simply did a 2-inch overlay on this project. And contrary to what we do on every other project now at CDOT, it's usually at the contractor's discretion. If he's going to use warm mix, he can. Pick an approved product that you're comfortable with and use that. However, on this job, we required that warm mix be used, and we required temperature behind the paver to be no more than 235 degrees. This was a 29-mile, 58,000-ton project. And there's always a little pushback when you try to mandate something that might shock people a little bit, and so we dug an awful lot into other places where demonstration sections were built or research studies were done to try to correlate temperature of the mat being compacted to the prevalence of bumps caused by cracks and crack sealant underneath. So we spent a long effort to try to make sure we were going to do something that made some sense and might give us a good chance of mitigating those bumps in the overlay. We had problems. We really needed to avoid this kind of situation. You can see peeking out from behind here, this is a brand new overlay on a similar highway adjacent to the one that we're talking about on Highway 9. That new overlay went right on top of a pavement that should have and would have at the time gotten a hot in place treatment, a heater scarification prior to the overlay because of all that crack sealant. Funding issues arose, and the project needed to cut a section of the pretreatment, the heater scarification, out and simply put the overlay directly on the crack sealed initial surface. And those bumps came right through, and well, we had a creative contractor in that image on the right, sharpened up a motor grader blade and just skimmed those bumps off. So that's not ideal. We don't want that, and we're looking for ways to get around it on a project 29 miles long. So here's the initial surface on Highway 9. See, those crack seals are like clockwork, 10 to 15 feet down the roadway as we go throughout the project. So pretty nervy just putting an overlay on this again with the experience you saw in that first slide there. Whoops, jumped the gun. So again, an SX75, that's a 75 gyration half-inch mix, 5828 binder. Mandatory warm mix on this project with a max temp of 235 behind the paver. Two technologies were attempted by the contractor on this, foaming for some initial 5,000 tons or so, and then Evotherm was used for the balance of the project. You can see some of the mixed details there as well. We had some failing lotments. We call lotments what most people call a TSR, or a tensile strength ratio. It's our way to test for stripping potential in mixes. Well, we had some failing lotments in this 5,000 tons of foam warm mix that was placed. We had some fines clumping pretty significantly and some issues with that, and checking during compaction at that 235 temperature. Concerning to us, a lot of it was milled out because of those failing stripping tests, and then the rest of the project was completed with Evotherm. So the mix was placed between 230 and 250. There was language in the specifications that we could, if we were diligent in not seeing cracks coming up, we could allow a slight increase in temperature to move through this project. It was pretty chilly at times. We paved into October, and so temperatures were between 230 and 250. No bumps were seen on the project, even in those areas with heavy crack sealant. So this is what it looks like today. There's some reflection cracks that have come through. This was placed back in 2009. There were some other mixed dryness issues that were associated with the contractor's control, and so we see some transverse cracks coming through. But boy, those bumps are not evident in this project. So there's some detail on two projects so far. I'm going to go through a bunch of additional ones, and these are going to be kind of quick, and it seems like there's going to be a lot of them, but I just really wanted to show you a lot of the places where we've successfully used warm mix to take care of some pretty tough conditions here in Colorado. So you can see them all listed here, and I'll go through these with you. Highway 121, or locally known as Wadsworth Boulevard. Heavy traffic here in Denver, night paving as a result. This is a 64-28 mix, polymer modified, 75 gyration half-inch. 40,000 tons right here in suburban Denver, entirely night paving between Labor Day and Halloween. temperatures below 30 degrees during the night paving on this project. Very well done. CCA is the Colorado Contractors Association. This won their Project Management Award, almost entirely due to the warm mix, according to the project people. Just went very well. Very high pavement quality incentives on the project. Density is included in the calculation of those pay incentives. One notable here from the project engineer, and maybe if there's discussion at the end, we can talk about it. They did have a little bit of concern with potential for the mix being soft, even at 150 degrees, and concerns that it might be marred when they opened it to traffic. So a little bit of guidance they're looking for is, hey, is it okay to open some of these mixes with additives in them? I've seen similar things on that I-70 project. A lot of it is very noticeable at flat light from oncoming traffic. When you're paving at night, you can see anything in the surface, abnormalities or anomalies in the surface, even from footprints. But none of those have I seen carry over into finished surface. So this is just a notable from the project engineer. I thought it'd be worth sharing with you. Very well done project, though, successful. This is on our interstate right through the guts of Denver, I-25, right near 20th Street. And you're right near downtown, right next to downtown in this location. This was a 100 gyration mix, SX, and a 64-22 binder. This was placed between, for a lot of reasons, had to be placed between December 13th and December 17th. Very cold weather, snow on the ground, night paving, high teens at night. One of the takeaways was, hey, this was a Christmas present to get something buttoned up, so Merry Christmas, Denver. This is State Highway 194. This is down in Region 2, a rural location, but very similar motivations to the Highway 9 project up near Hartselle that I showed you high in the mountains. Not the added challenge of low temperature conditions at 10,000 feet. This is probably around 5,000 feet or so, but very significant transverse cracks on this project and the need to simply get away with an overlay. This is a 75 gyration SX mix, 64-22. Again, they had a max 235 behind the paver. Again, not a cold climate, but we really wanted to make sure we didn't have those ugly bumps coming through. You can see in the photos here, there are some bumps that did come through. In the right one, looking in the right lane as you're going down, they're addressed in that location, but you can see in some spots, the left picture and in the left lane, there are still some bumps that came through. There was apparently some wrestling matches that went on at the contractor's plant between the owner and his son with trying to really dial in what should be the temperature for running that plant, because it's new for warm mix, and it's hard to believe that you should actually run it at a lower temperature for some folks. So there were some battles at the plant, and mix came out a little hotter at times, and we saw some bumps come through. Here's another one on I-25. This is I-25 down by Colorado Springs, which is a large metro area immediately south of Denver. This was a 100 gyration SX 64-22 mix. This was a huge design build project that they really needed to wrap up before winter fully kicked in, although they didn't quite make it. So we went right into December with paving on this major reconstruction and widening project. It was necessary, they found, to limit paving to 25 degrees and higher and 15-mile-an-hour winds. That's way lower than we would typically pave. But up to that point, they could get good density and did so on the project. They had great density results, but they began to drop in density if you went below that. So a little bit of project-specific knowledge had to be learned on this. They did that through increasing density testing early on, again, to make everybody comfortable with what they were capable of in paving at temperatures lower than we've historically been used to paving. Good compaction even during those colder temperatures. Things did start to drop in December, but they were still 93, 94% right there within specification. The project people on this one wanted me to note that they've also placed SMA in their region using the additives that were used on this project. So good success here in a very big project. This is State Highway 145, so going from a metro location to the middle of nowhere. This is way out in the southwest part of the state. Rico to Lizard Head Pass. And a 5834 binder, that should tell those of you that know that this is a pretty cold climate. An ST mix, that's our 3/8 inch mix that we use for thin lifts, oftentimes for initial lifts prior to putting something structural on top. There was a 1-inch ST lift on this project. It had, as you can see, very high 7.3% AC. They didn't feel they needed any additive in that, but there was a warm mix additive placed in the SX in a 1.5-inch lift on top of this. So that's still a relatively thin lift. You know how thin lifts cool down quickly, and in cold climates with winds, it's a concern. There was a 1.5-hour haul, an hour and a half, and this was being paved late in October at a high elevation. So they did pave below the 50 degrees, but they watched it pretty carefully because with winds and cold temperatures and a thin lift, they had to be very careful to keep tabs on testing and make sure they could still get compaction. The takeaways on this one, they got quality incentives for all of the items. It did have some bad joints constructed, had nothing to do with the warm mix, but in control of and the straightness of the joints, it's difficult to get density on something that you can't match. Very excellent properties by the contractor and his compaction on this mix in a pretty tough location. State Highway 141, Slick Rock. This is out in the high desert, southwest Colorado. There was a rut filling and then a leveling course with a 2-inch warm mix SX75 on top. 3.5-hour haul. So there's no plants in this location. There's not much of anything in this location. You can see the watch out for cows sign because you'll see more cows than cars. 3.5 hours from the plant to this project, and they had no issues with opening immediately after compaction. Additive was used to be able to facilitate compaction after a long time in the truck. So they had no significant clumping within the truck after 3.5 hours upon load. It was belly dumps, and they were a pickup machine to pick them up, so they were able to get any remixing necessary if there were some colder locations within that truck of mix. No drain down in those trucks. The mix was produced at a conventional temperature, but knowing it was going to have to travel for 3.5 hours before it reached the project. Great density control reported on this project as well. So this is one where they're extending the paving radius from an existing plant. Really necessary in states where you have a lot of remote locations and difficulty in supply. There's almost too many for me to name here. I threw a couple of others that are going on right now here at the bottom. These are happening. I-70 frontage road in 20 degrees. That was this past construction season out in western Colorado on the west side of the state. I-70, an extension of what I talked about first. I-25 right now in the Metro Denver, we've got that being paved and some interchanges, both with warm mix to facilitate. I think tonight it's going to get down into the 30s. Vail interchange. Vail is up in the mountains, as you might know. They're expecting to finish paving on that perhaps right about the time they open the ski area up. So we have a lot of project examples here. I tried to give a good cross-section of the kind of different ways we've been able to benefit from warm mix. I think we've really been successful, and I think we've had some conditions we just couldn't have dealt with without the ability to compact in tough conditions and the additives that have helped us out. We've really been able to maintain the quality of our mixes even when using some types of additives. Part of that is we've got a process in place to ensure that we still have the asphalt content in our mixes that we've historically had, and there's not any method to reduce that because of some compaction aid in there, so it's been excellent. Our process has proved itself, I think. We've been able to increase haul distances. We've been able to extend paving seasons. We've had excellent compaction in very tough cold conditions, and we've been able to, when needed, target a specific paving temperature, reduced paving temperature, as I've shown in those slides with bump issues. We're going to continue to rely on warm mix in Colorado. It's just been too good for us and helped us in so many ways. So that's some cross-section of experience here in Colorado, paving in challenging conditions. I'm going to show you something a little warmer here while you're thinking about your questions. Winter's upon us. For those of you going to tropical locations, enjoy yourself. Open for questions.
Yeah, and feel free, guys, you're more than welcome to just unmute yourself and ask the questions, or you can, again, feel free to chat them in the lower left-hand side of your screen, and we'll be sure to get to them all and answer them. Okay, so we have Manoj Joji, who's got a hand raised. Go ahead.
I sent the question.
Great, Father. We don't have a process for testing for the presence of the warm mix additive at the volume that is recommended by the supplier.
So hang on, Bill. The question is there a process in place to check if the warm mix additive is present in the mix and at the right volume? Go ahead.
Correct. No, and we haven't had a concern about that because for every single project we've had, as we've prescribed, it's a hot mix design through which we establish production targets, most critically for the asphalt binder content, and then we hold that through production, and the contractor drops in the additive at whatever dose is necessary to facilitate the conditions he's got on the project. Either he wants to produce at a lower temperature or he wants to compact 200 miles from his plant or at a high elevation in cold times. He's to choose what the dosage is that goes in it, and we maintain the target for asphalt content at what we established based upon the hot mix design. So hopefully that answers you as to why we don't really verify what his dosage is.
Jim, we have another question about compaction numbers. So are you seeing good compaction numbers with air temperatures below freezing with all improved chemistry, or do some perform better than others when air temperatures dip below freezing?
In the projects, just those that were listed here, we've had plenty above and plenty below freezing temperatures. We've represented at least in the more detailed slides here at least two different types of additives shown. We've had another third that's been used in several other locations as well. We haven't seen a sort of a trigger point that leads to compaction shutdown at freezing at all with any of those. So no, I guess to say below freezing, below 32 degrees, we haven't noticed any challenge besides just the temperature sensitive viscoelastic properties response to a decreasing temperature, but nothing relative to freezing point that has triggered a sudden drop off in the compactability in the mixes with any of those three additives we've seen a lot of. It's important though. I mean, mixed cooling is important and different at very cold ambient temperatures. Mat temperature has a pretty significant influence on it, but the temperature gradient across those layers can be pretty significant. If it's 20 degrees outside or 10 degrees outside, the ground is usually not that cold, and you can cool quite quickly at the surface. So you really need to keep an eye on, is there any checking being caused in the mats, and if so, you may need to shut down. Even though you might apparently be able to reach density, you might damage the mat, and we've counseled our folks to keep a close eye out for mat damage when paving at colder and colder temperatures, because regardless of getting density, you shall not crack the mat, and it's something to be aware of and have your inspectors and field staff look for as you try to pave at lower temperatures, because that temperature gradient can cause problems that aren't captured necessarily in density measurement.
We have another question that's come in, Bill. It's asking which additive was used for the project where there was a 3.5-hour haul.
Gotcha. I believe that one was Zycotherm. We've had a bunch of Evotherms as well used for some longer haul projects as well by that same group. Successful amongst the technologies they've tried. They were pretty happy.
And then as a secondary question, it's being asked, is the additive added at the supplier facility directly into the binder, or are the additives added in at the plant?
That's going to depend on the additive supplier. However, most of the Evotherm supplied is supplied at the binder supplier. It comes in the tanker truck from the supplier facility. That's why we have QC requirements for how they control that introduction at our binder manufacturers. I've also had projects where we've had the Evotherm delivered right at the plant through attachments to the feed line at the plant. I believe the Zycotherm and some Sika-based products have been added typically at the plant as they're getting off the ground in working with the market and working with contractors. Most of those right now are delivered at the plant. But the majority of projects, it's coming in the package with the binder from the binder supplier.
We have another question asking about the future of projects in Colorado. So what are CDOT's plans for mandating more warm mix asphalt projects in Colorado in the future?
In talking with our industry and in keeping with what we thought is the most effective way to see warm mix being used, it's going to continue to be a contractor selection as to whether or not it suits his project demands to use warm mix in his mix or to use it in part of the mix on the project. If they're going to go through the process and use approved materials and follow the process, they can use it as they wish. We have mandated it, as you've seen in a couple of instances here. We may have to do that periodically in the future, but for the most part, it is allowed on any project across the state. We encourage it as contractors need it to deliver quality projects for us.
Do we have any other hands raised or any other questions from the audience? It looks like we've gotten through most of our chat and other questions at the moment. Okay. If that's it, and Bill, do you have anything else that you'd like to add before we end today?
No, I sure don't. I see Jeremy Lucero's online. Jeremy, I covered some of your projects very quickly. Anything to add from our guy right out there on a lot of these projects, Jeremy? And he might not be dialed in. Anyhow, no, I have nothing else to add. It's fun to go through the list of people here. Hey, Oak, hope you're doing well.
For those of you that have colleagues that weren't able to join us today, shortly after we end the call, I'll be posting the recast of this webinar on our YouTube channel, which is just Evotherm WMA, and then it'll also be on our Connecting the Dots webpage as well. But I'll send a note out to those on the call to inform you of where you can follow up as well. We will also, for each of you participating today, be sending out professional development hour certificates. So if you need those, welcome to use them. If you don't, that's just our parting gift, and you don't need to use it. But we hope this has been very helpful. Thanks so much for joining us, and please stay tuned for future Connecting the Dots webinars. Have a great afternoon and a wonderful weekend.
Thank you.
Bye-bye.